Question says the de Broglie wavelengths associated with an electron and a proton were calculated by accelerating them through the same potential of 100 volts. What should nearly be the ratio of their wavelengths? So for an electron we have lambda e to be equal to 12.27 upon root v Armstrong. 12.27 is a constant which we find out, and this is a formula for a wavelength of an electron. Then we have wavelength of proton to be equal to h upon under root of 2m v cube. Now for proton, now when we take the ratios of these two, we have lambda of electron upon lambda of proton to be equal to mass of proton upon mass of electron. Now it is given to us that mass of proton is 1.00727 and mass of electron is 0.00055. Now taking ratio of both of them, we have the mass of proton upon mass of electron to be approximately equal to under the root of 1831. This is nearly almost 1600, which is equal to somewhere around 40 to 45. So when we take the square root, we have approximate value as 43. So therefore we have lambda of electron upon lambda of proton to be equal to 43.